Good evening, sir. Can you hear me?
Yeah, good evening. Uh, yeah, I can hear you. So, today's class, we are going to discuss some theory uh, problems. You have to keep attempting till the last sheet. I think problems till 180, 190 I had shared, right?
Yes, sir.
So,
Yes, sir.
you have to try those. The doubts in that we'll be discussing in the next class. So, today I want to cover some of the theory that you need to know. Uh, So the first thing that we'll start off with is midpoint theorem. Many of you already know this, but I will state it anyway. So if you have any triangle ABC and you'll connect the midpoints of two sides AB and AC, let's say D and E. If you connect that, then we know that DE will be parallel to BC and the length of DE is equal to half of BC. Here D and E are midpoints. So this is one of the most important theorems in triangles. Like you need to know this, and the proof of it is pretty easy. You should try to do the proof of this. So assume that you have connected midpoints. Now prove that D is parallel to BC and D is equal to half BC. It's a simple proof by similarity. You can prove that ADE is similar to ABC, right? The reason is that there is a common angle and the other two sides are proportional and the ratio is 1:2. From there we get that DE is half of BC also, and you also get that this angle must be equal to this angle, which makes DE parallel to BC. So basically simple similar triangles will help you prove this theorem. I hope everyone understands what I have done.
Yes, sir.
Yes, sir.
Okay. Then the next theorem is this one. For a trapezoid for a trapezoid ABCD with AB parallel to CD, AB parallel to CD, if E and F, if E and F are midpoints of AD and BC respectively, then first of all, just like in midpoint theorem, EF will be parallel to AB parallel to CD. And you can also say that this line, the midline, is equal to half of AB plus CD. So basically, the theorem is like this. You have, this is the situation A, B, C, D, and midpoints of these are connected. This is E, this is F, and this is a trapezium. So opposite sides are parallel, these two opposite sides. The other two sides are not parallel. And you can prove that if you connect the midline E and F, where E is the midpoint of AD and F is the midpoint of BC, then EF length will be equal to half of AB plus CD. And obviously the line EF will be parallel to both AB and CD. Now try to do the proof of this. The proof is easy if you can draw a diagonal. If you draw a diagonal, then there will be a triangle. And if you call the midpoint of the diagonal BD as G, you can prove that G lies on the same line. So you should first assume that it is not on the same line and then try to prove that it is actually lying on the same line as E and F. The reason it is doable is because we already know that this is parallel to this. Since we already know parallel, we can say interior alternate angles are equal and all. So similarity will be easy to do. So you should try by making a diagonal and applying midpoint theorem on triangle BDC. Is everyone understanding the idea what I'm saying?
Yes, sir.
Right. So
Done.
what is someone saying
Yes, sir,
something?
getting the idea.
Basically, one side midpoint is already known. You assume G is the midpoint of BD. Then you can say EG is the midpoint of this triangle, midline. And GF is the midline of triangle BDC. And we should know EG is parallel to AB and GF is parallel to DC. So since AB and DC are parallel, EG and GF have to be the same line. I hope everyone is following.
Yes.
From there, you can prove that the other part also can be proved because you can say EG is equal to half AB and GF is equal to half DC. And EG
Yes, sir.
plus GF is equal to EF. So that is an important idea. It is an application or extension of midpoint theorem, but now to trapeziums. Try this question. A trapezoid ABCD with bases AD and BC is such that AB is equal to BD. Let M be the midpoint of DC. Prove that angle MBC is equal to angle BCA. You are given that M is the midpoint of CD and AB is equal to BD. And you have to get that angle MBC. Okay, I have made the wrong angle. So we don't have to check these two angles. We have to check the other two angles. MBC is this angle. We have to prove that this angle is equal to BCA. So this angle. If you try to directly do it, it is a little annoying. What you should do is extend this line and extend this also. And let's say they meet here at K and you can join C and K. What have I done? I have extended the line BM such that it meets the base AD at an outside point K. Now, what is the benefit from that? The benefit is that we know that BC is parallel to AD, right? That is known because it was a trapezium. So, BC will be parallel to basically AK also. And if it is parallel to AK, then we can say that this angle is equal to this angle by interior alternate, right?
Yes, sir.
Similarly, this angle, this big angle, BCD will be equal to this angle. Again, interior alternate angles. And we also know that this vertically opposite angle will be equal here. So you can say that triangle BCM is similar to triangle MDK, right?
Yes.
But we also know that M is the midpoint of CD, so MC is equal to MD. So
They
similarity
are
plus,
congruent.
right? So they are congruent triangles. So if they are congruent triangles, now we know that everything is same in these two triangles. So we can say that the side length and all will be same also. So we know that DK will be equal to BC, right? We also know that MK is equal to BM, right? Correct. Okay.
Yes,
So
sir.
if these two triangles are congruent, think of the quadrilateral BCDK. Think of the quadrilateral. This is parallel to this and equal length. Opposite sides are equal and parallel.
Parallelogram.
So this becomes a parallelogram. If this becomes a parallelogram, then BD is equal to
BD.
CK.
And parallel also.
And BD is equal to CK means BD is equal to AB. So we are getting
Oh,
CK is equal to AB, right?
Yes, sir.
So now we are getting ABCK is a trapezium where CK is equal to AB, right?
Yes.
Yes, sir.
ABDC was not such a trapezium, but ABCK is such a trapezium where the other non-parallel sides are equal. It is known as an isosceles trapezium. And in an isosceles trapezium, now it will be very easy to show that if this is the situation, it is such that this and this are equal. You can very easily show this angle has to be equal to this angle. What you need to prove is that one diagonal of the trapezium makes an angle with this base, and the other diagonal also makes this angle. You have to show that both angles are equal. It is obvious because the lengths of these sides are same and the perpendicular distance between the parallel lines will be same in both the situations. Do you understand what I'm saying?
Yes.
Yes, sir.
If you have an isosceles trapezium like this, it is not difficult to prove that this angle will be same as this angle because this side is same and these are parallel lines, so perpendicular distance is also same. So these two triangles, you can use sine rule also and do it, basic trigonometry, or
Hmm. We can do.
what else can you do? You can prove congruency or similarity here in this triangle
Yes,
and
sir.
this triangle,
Hmm.
right? So that finishes off the question. The main idea is to extend it and make it a isosceles trapezium.
Yes, sir.
The next problem is this: the angle bisectors of an isosceles trapezium, intersect at a point P, intersect at a point P, an angle formed by a pair of bisectors is 60 degrees. Is 60 degree. One of the angles is 60-degree, and you have to find the other angles of the trapezium. Find all the angles of the trapezium.
Sir, the bisectors are concurrent at P.
That's what it is saying. No?
Okay, sir.
If you take an isosceles trapezium like that, this angle and this angle have to be same because it is an isosceles trapezium. We can call it as 2 alpha and 2 alpha. Then this angle will be 180 minus 2 alpha, and this will be 180 minus 2 alpha. Is everyone understanding what I'm saying?
Yes, sir.
Yes, sir.
Draw bisectors, and the bisectors are concurrent at this point P. So we first of all know that 2 alpha is less than 90, so alpha is less than 45. And then we have alpha here, and this angle. So this angle is bigger than 90. So this angle must be 60, right?
Yes, sir.
So this is alpha, this is 90 minus alpha. So
नहीं
1 second, something is wrong. Okay, so this cannot be 60 then. This has to be 90 then, right? So this must be 60 then. Because we have 90 minus alpha, 90 minus alpha. So we have total is 180 minus 2 alpha. And this must be 2 alpha. So 2 alpha
Yes,
must be
sir.
60.
Yes, sir.
So we are getting alpha is 30 from there. And then we get all the angles. This is 60, 60, and these are 120, 120. And this angle is 60, this angle is 90, 90, and this angle is 120, right?
Sir, if it's 90, how can it be 120?
What do you mean? These two vertically opposite angles will be 90, 90, no?
Then that will also be 90, right? Angle APB.
1 second. Okay, so then something is wrong.
Sir, ADP should be 120 minus alpha.
ADP should be
120 minus alpha.
why 120 minus alpha?
It should be 90 minus alpha only.
Because it's the bisectors.
Yes, sir.
P is the intersection point of the four angle bisectors. So maybe they are not collinear. That's the issue. They are not going to be collinear.
Sir,
The
how
sum
can we
of the
just
angles has to be adding to 360. So you can't say that this bisector and this bisector are in the same line.
मतलब they are not collinear, like they're not in a single
So
line.
you cannot say that this is adding up to 90, 90, 90. Do you understand what I'm saying? The total
Yes, sir.
angles has to add up to 360, but they are not collinear, right?
Yes, sir.
So that is the confusion. Uh, okay, then the next question is this one. Let ABCD be a square and E belongs to BC and F belongs to DC. These are points that lie on these line segments, BC and DC. If angle BAE is equal to 15 degrees and angle DAF is equal to 30 degrees, find angle AEF.
Sir, 60 degree?
No. Be careful, don't make mistakes. This is a very easy question. Is anybody getting any ideas? No one has any clue what to do here. There are two ways to do it. One is trigonometry, which is brute force. That method is there for anyone. The other method is geometry. Since we have learned trigonometry, if you cannot figure out a geometric solution, you should be getting it by trigonometry. It's a square. Have you guys forgotten that it's a square? Nobody is saying anything. But the trigonometry solution I am not going to show. It's obvious. We can find this side length. It will be a by root 3 if a is the side a of the square. We can find this length easily. Once we know this length, all we need is this length. It's not very difficult to find this length because you know 15 degree here. And this is a tan 15. I need to calculate. I will get everything, this and this, right? By brute force calculation, everybody should be able to find side length x and y.
Yes, sir.
Yes, sir.
And if you know x and y, technically you can even find this because this will be a minus a by root 3 and stuff. So all the sides are known. One angle is being asked. It's cosine rule.
Yes, sir.
Trigonometry solution is simple, just a little bit of work. But that is not the solution that we are going to talk about. I'm not going to show the rest of the trigonometry solution. It's super obvious. So we are going to look at a different solution which is not involving trigonometry. This is the situation. This angle is 30 degrees and this angle was 15 degrees. And this point was E and this point was F. What I'm going to do is I'm going to extend this side to such a length that this point S, BS is equal to DF. This is by construction. Do you understand what I'm saying?
Yes.
So now I join this, and now what we will look at is because BS is equal to DF and 90 degree and one side is here, one side is here. By SAS it is congruent to this, right? Triangle ABS is congruent to triangle ADF.
Yes, sir.
So obviously this angle is 30 and this is 90 and this is 60. We know all this, right? Correct.
Yes, sir.
Now, if you look at triangle AES, in that triangle, if you'll focus on this angle is 45 degree. It is the same as this angle,
This
which is
angle.
also 45 degree.
Hmm.
Okay. So EAF angle is equal to EAS angle, right?
Yes, sir.
Fine. Now, we also know that AF length is equal to AS
Yes, sir.
because of the congruency, right?
Yes, sir.
Okay, so AF is equal to AS, and so basically we are getting in
SAS
triangle,
congruency.
this side is equal to this side, and this is a common side, right? AE is common to both the triangles. Which two triangles? Triangle AEF and triangle AES, right? AE is a common side. AF is equal to AS.
Sir,
And middle
in
angle
the-
is 45.
In the question, it was BAE is equals to 40 degree. 15 degree. Yes, sir. 45.
That 15 is for this only.
Okay, sir.
We have a congruency by SAS here.
Hmm.
If this is congruent, then we know that triangle AES is congruent to AEF, and therefore the angles will also match now. So we have 45 degree here, and this angle is opposite to AF here. So opposite to AS here would be this angle, right?
60 degree. Yes, sir.
What do you mean 60 degree?
No, sir, the opposite one, angle AEB.
This is the angle that matches this, not 60 degree. It is 75. How are you saying 60 degree? This is the equal side of the congruent triangle here, and this is the other equal side.
Okay, sir, got it.
The angle opposite to it is this angle, which is matching this angle, right? The 60 here will match the 60 here. Do you understand what I'm saying?
Yes,
This
sir.
is opposite to AE here, and opposite to AE here is this. The answer is 75 degrees. And in order to get this, we needed the construction of a equal length on this. Now, if you cannot think of the construction, it will be difficult to solve it by pure geometry. If you can't think of the construction, it will be slightly annoying. Then your best hope is trigonometry. That's why we did all that trigonometry in the first 10 sessions, no? So that you can do trigonometry and figure it out if you can't do it by pure geometry. So if any of you are struggling with, like, you're not able to think of this construction type of situation, then use what you can do. Solve it by trigonometry. It was not very difficult. Does
Yes,
everyone know how to find the value of tan 15 and all?
Yes, sir.
Yes, sir.
So trigonometry should have been available to everyone, the solution there. If you know cosine rule and triangles and tan theta and all, you should be able to do it. Okay, the next theorem that we want to talk about today is angle bisector theorem. Angle bisector theorem. So basically, the theorem says that if you have any triangle ABC and you draw an angle bisector of any angle, let's say it meets the opposite side at this point D, then the angle bisector divides the opposite side in the ratio of the sides that make up the angle. So for example, this side is referred to as usually small c, and this side will be referred to as small b. What we can say, the theorem says that BD by CD is equal to C by B. Is everyone understanding what I'm saying?
yes, sir.
Yes.
So what you can also say is that BD plus CD is equal to A. This whole length is called A. And if it is C by B, the ratio, we can say BD is CK and CD is BK. So we can get CK plus BK is equal to A, and from here we'll get the value of K as A by B plus C. Once we get the K value, we can actually find BD. BD is basically CA by B plus C, and CD is actually BA by B plus C.
Yes.
Is everyone understanding what I have done? Angle
Yes.
bisector theorem gives us a ratio, but we can use that ratio to find the actual lengths, right? Now, this angle bisector theorem, the proof is very standard and you need to find it yourself. Find the proof. I'm not going to discuss it. Find it yourself. If you don't get the proof, you can search online anywhere, you'll get it. But you need to know the proof of angle bisector theorem also. It will involve some parallel lines. I hope everyone has seen that proof somewhere in life before.
Yes, sir.
So there will be some parallel line that will be drawn. Okay, I'm not going to discuss the proof here. This theorem is super important. The next one is the centroid theorem, which is also familiar to most of you, I think. It says that the three medians are concurrent at a point called the centroid. Three medians are concurrent at a point called the centroid. And the centroid divides any median in the ratio. What is the ratio?
2:1.
2:1. Any median in the ratio 2:1. So basically, first of all, what is a median? It is a line from a vertex to the opposite midpoint. So this is a median. Similarly, this will be a median, and this will be our centroid. The point of intersection of any two of them will give us the centroid's location. The third median will also intersect here at G. And what we are saying is AG by GD ratio will be same as BG by GE ratio and will be same as 2:1. Again, this theorem is also easy to prove. You should just draw this ED line like this. This becomes the midpoint, right? Midpoint theorem. Correct?
Yes.
Try to prove this theorem also. If you don't get the proof, I will discuss it in the next class. But everyone should get it actually. You might have seen it before also. Have you
Yes.
guys, any of you, seen the proof like this before? 2:1, this proof.
Yes.
Okay, so make sure that you revise the proof and know the proof, know the meaning of centroid, what is it, and so on. The next thing is basically two things which are very important: Sheva's theorem and Menelau's theorem. These, what we will do right now is we'll state and understand the theorems, and in part 2 of the course we will have a separate section on it. So we'll do the proof in detail and also look at the trigonometric versions of these theorems. For now, I'm giving you the pure geometry version, so just try to understand what it is right now. So Sheva's theorem is this: given a triangle ABC, let the lines AO, BO, and CO be drawn from the vertices to a common point O, not on any of the sides, of triangle ABC, and these AO, BO, CO could be extended to meet the opposite sides at D, E, and F respectively. So AO, BO, and CO can be extended to meet the opposite sides at D, B, E, and F respectively. Then we can say that AF by FB multiplied by BD by DC multiplied by CE by EA is equal to 1. So try to understand what the theorem is saying. We have a triangle ABC, and there is some point, common point O, which is the point of concurrency of these three lines. AO, BO, and CO. Let's make the point O somewhere here. The only condition is that O is not on any of the sides. Is everyone understanding what I'm saying? This
Yes,
is
sir.
my point O. So AO,
Yes, sir.
BO, CO. It can be anywhere. It can even be outside the triangle, anywhere. AO, BO, CO. Now we'll extend AO and it meets the opposite side at this point D. Extend BO, E, and extend CO and it meets the opposite side at F. Now what the theorem is saying is that AF by FB times BD by DC times CE by EA is always going to be 1. Now, it is important to be able to write the condition from Sheva's theorem correctly. And notice that all the line segments are in a clockwise ordering.
Yes, sir.
So, AF by FB, BD by DC, CE by EA. That is a nice pattern.
Hmm.
By the way, the lines AD, BE, and CF are sometimes called Chevians.
Yes, sir.
Any lines from one vertex to the opposite side of a triangle can be called a Chevian. There are some Chevians which are special, like angle bisectors or medians. There is nothing special about AD, BE, and CF right now. These are 3 random lines drawn from the vertices to the opposite sides. Do you understand what I'm saying right now? The point
Yes,
of
sir.
the theorem is that these 3 lines are concurrent at O if this condition is true. These 3 lines will be concurrent if this condition is true. If this condition is not true, the 3 lines will never intersect at one common point.
Oh, sir, ऐसे तो फिर like we can do for median and everything like ortho center and all. We can
Yes,
prove
you
that.
can do it. You
Hmm.
can get things like what is the if you made these lines as altitudes, for example, right? Then
Hmm.
the common point becomes orthocenter, and you
Hmm.
can say that BD by DC times CE by EA times AF by FB will be 1.
Hmm.
So you can confirm from your information about orthocenter and those lengths on the bottom whether it is becoming 1 or not. So basically, if you know Sheva's theorem, this gives you an alternative way to prove that orthos and altitudes are concurrent. Is everyone understanding what I'm saying right now?
Yes,
Yes.
sir.
Basically, any triangle I have and somebody makes 3 lines, random lines, and if I have to prove that the lines are concurrent, then you can use Sheva's theorem. If they have to be concurrent, always the ratio here AF by FB, BD by DC, CE by EA has to be 1. If the ratio is not 1, it is not concurrent. That means it could have been like this. If it is not concurrent, what is the situation? It is like this, and maybe the third line is like this, right? In that case, they are not concurrent. In that case, you will not get that condition. I hope everyone understands what I'm saying.
Yes, sir.
So this gives
Yes, sir.
us an alternative way to prove that let's say angle bisectors are concurrent. I have to prove this, right? So I'm going to say that let's say these are angle bisectors, or let's assume that they are not concurrent. We'll do by contradiction, right? Let's assume they are not concurrent. And let's say when the angle bisectors intersect, I will find these ratios, right?
Hmm.
So I know already from angle bisector theorem what is BD by DC, right?
AB by AC.
So BD by DC is simply AB by AC. Similarly, what is CE by EA?
CB by AB.
Right. By angle bisector theorem, we are getting these things, right?
Hmm.
And AF by FB by angle bisector theorem would be.
AC by BC.
So now we can see that the product of these three things is actually one because all of this is getting cancelled.
Also, we can also prove like from the I where it
There
intersects.
are
we
many
can-
other ways to
हाँ,
prove, but do you
हाँ.
understand what I am saying right now?
Yes, sir.
The product of these three things is becoming one, which means the condition for Sheva's theorem is being satisfied, which means that the lines AD, BE, CF are concurrent at a point which is the incenter, right?
Yes, sir.
So you can use this as a condition to test for concurrency. The proof of Sheva's theorem and trigonometric Sheva we will do in a separate session. Like we'll spend a lot more time on it, but right now we are not doing it. Probably in like 2-3 weeks. So we'll do it later. I'll talk about Menelau's theorem now. If everyone has understood the first one, Sheva's theorem you have to understand first. Is that clear to everyone?
Yes,
Yes,
sir.
sir.
Okay, given a triangle ABC, let D, E, F be the points on lines BC, CA, AB respectively. These are three random points on the line lying on the three sides. Then we can say that D, E, F are collinear points, are collinear if and only if AF by FB multiplied by BD by DC multiplied by CE by EA is equal to 1. And an even number of D, E, and F lie on the sides of triangle ABC. So understand the condition first. So Menelau's theorem is about collinearity. Sheva's theorem was about concurrency, right? So look at this triangle right now and let DEF be points on the lines BC, CA, and AB. So imagine AB's extension and this point is F. Imagine E somewhere here and imagine D somewhere here. Do you understand what I'm saying right now?
Yes, sir.
So right now I have chosen the points in such a way that you can imagine that there is a line through them, right?
Yes, sir.
I'm not able to draw it clearly, but you will understand what I'm trying to say. There is a line passing through DEF. It's a collinear set of points, right?
Yes, sir.
Now, the condition for it to be collinear is, again, AF by FB. Notice this is slightly weird. AF by FB, BD by DC, and CE by EA. So here F is outside the triangle, but you are doing AF by FB. The ratio is still AF by FB only, as if it was inside. Do you understand what I'm saying?
Yes, sir.
Yes.
Basically, the ratio is the same as the ratio that we saw previously, for concurrency in Sheva's theorem.
Yes, sir.
So AF by FB, BD by DC, and CE by EA, the same ratio, even if one of them could be outside the triangle, right? So if this ratio product is becoming 1, and what is the second condition? Even number of DEF lie on the sides of the triangle.
इसका
right,
मतलब समझ में नहीं आया.
so right now what that means is you can say that F does not lie on the side of a triangle, right? Because F is outside. F is on the extension.
Yes, sir.
But E and D are on the sides of a triangle.
अच्छा, okay.
So out of the 3 points, 0 or 2 should
Can be out or in.
lie on the triangle.
Okay, sir.
0 or 2 of them should lie on the triangle, and this condition should be true. Basically, even number means that only, right? Do
Yes,
you
sir.
understand what I'm saying? It should not be that all, like,
Sir,
it is possible that all 3 of them are not on the triangle. Is it possible? Yeah, it is possible. 0, right?
sir,
Hmm.
sir, isn't that BC by DC in the theorem?
Here,
No,
no,
sir, like in that theorem. Yes, sir, yeah, there.
no, it is BD by DC only.
Yes, sir.
It is BD by DC only. The order is preserved. You have to imagine everything as inside the triangle and write the ratios as if it is like that. Imagine F also inside the triangle. It would be AF by FB, BD by DC, and CE by EA, right?
So the thing goes like Siva's theorem only.
The product is like Sheva's theorem only. But some points could be actually on the extension, not inside.
Yes, sir. Got it.
More than one could be on the extension. Two of them could be on the, like in this case, we have two of them on the triangle and one of them on the extension, right?
Yeah, but they can two of them cannot be on the extension because even number has to be there.
Even number has to be on the triangle.
Hmm.
It cannot be one point is on the side of a triangle and two of them are outside. So usually people don't specify this condition. This condition is important, this last part, this part.
So because then only collinearity will resolve.
So we are saying collinearity happens if this thing is satisfied and at least two of them or none of them should lie on the sides of the triangle, right?
Yes, sir.
It is possible that all three are on the extension. What I'm saying is it is possible that all three are on the extension and still you get collinearity, right?
Sir, is it possible?
Yeah, all three, no? Means 0 are lying on the triangle. All three could be on the extensions.
Yes, sir. Yes, sir. It's possible.
If you draw it and see it, you can possibly construct a situation like that. Like there is a point here, there's a point here, there's a point here, right? You can imagine.
Yes,
These
sir.
3 points are collinear. But when you write the ratio, imagine everything to be inside and write the ratio like that.
Sure, sir.
Do you understand what I'm saying? Because it is very confusing to write this ratio. This ratio you should always write as if all 3 points are inside. AF by FB, BD by DC, CE by EA. Right?
Yes, sir.
But in reality, it could be outside and stuff. So remember, Sheva's theorem is about concurrency of 3 Chevians, and it can be used to prove concurrency of any 3 Chevians. And Menelau's theorem is about 3 points lying on the sides of a triangle, could be inside the triangle, could be outside the triangle, whether those 3 points are collinear or not. Right? I hope that much is clear to everyone.
Yes.
Yes, sir.
Okay, so what I want you guys to do is try to finish the assignment that I had sent earlier, and I'll be sending more questions by tomorrow. On Saturday's class, maybe we can do a class before that also. We'll discuss doubts
Okay,
so
sir.
far.
Yes, sir.
So we'll stop at the theory here. Make sure that you do the proofs of the stuff that we have not proved. Don't worry about Sheva and Menelaus. That we'll do it in detail later. But other than that, all the theorems that we saw today, make sure that you do the proofs and know the proofs. Right?
Yes, sir.
Okay, that's
Sir,
all for
I
now.
have a question.
Hmm.
Sir, do you have like any assignment for IQM integer type questions
No,
for this
nobody
exam?
nobody
Okay.
makes assignments for those things. We are not preparing for IOQM. IOQM ki preparation should happen automatically if you are doing the work that we are doing, right?
Okay, sir.
Forget about IOQM, dude. It's too easy.
Sir.
Right now, if you are working as per the plan, we are preparing for RMO.
Hmm.
That is the goal. That is what you should focus on. इंटीजर टाइप और वो सब करके अभी क्या होगा, वो सब तो हो ही जाएगा अगर तुम कुछ जो कंटेंट सीख रहे हो वो सीख जाओ तो.
Yes, sir.
Don't worry about all that. Focus on the work. Make sure you finish all the problems, as many as you can do, and learn all the theory that we are learning, right?
Yes, sir.
Okay, I'll see you in the next class. Try to do as many questions as possible. We'll finish all the doubts. Try to finish all the doubts in the next class. In
Yes,
the
sir.
sheets that are shared so far, I'll be sharing another sheet in the next 1 or 2 days that will cover theory that we discussed today onwards. Okay,
Okay.
fine.
Yes, sir.
That's all for now then.
Thank you, sir.
Hmm.
Thank you, sir.